Hi Anand, I'm hoping that you are watching this lecture. In this lecture, I'm going to cover a whole chapter of nuclei. So basically, now let's do this. Okay. So first of all, uh, I need to clear some things. What are those? First of all, I'm going to talk about A. What is this A? A is nothing but it is called as atomic mass. Okay. It is called as atomic mass. What is atomic mass? Atomic mass is nothing but it is the sum of number of protons plus number of neutrons plus number of neutrons. The sum of these two things is called as atomic mass. Okay, it is called as atomic mass. Now, this is known as atomic mass. So there is a another important term which is called as Z, which is called as atomic number also. Okay, what is this atomic number? Atomic number is nothing but it is the number of protons. It is number of protons. So let's take an example for this. Generally, we symbolize we symbolize an element like in the form of like in the form of x, a, and z, where a is the atomic number, a is atomic mass, z is atomic number, and x is being element. Okay, x is being element. So this is the general representation of an element. So if I'm talking about like we are having as carbon. So we know that the carbon having atomic number as 6 and atomic mass is 12. So if we need to find out that what is the number of neutrons, if we need to find out number of electrons, number of electrons, and number of protons. So how we are going to determine that? So if you want to find out number of neutrons, so there is a uh, so there is the atomic mass which is given to us, which is equals to 12. Okay, and if we want to find out the number of neutrons, then we should be having the knowledge of number of protons. So what are number of protons? The value of z is nothing but it is equals to number of protons. Okay, it is equals to number of protons. So it is having like number 6. So we can assume that we can say that the number of protons is 6, and in accordance of that we can find the value of number of neutrons. It is number of neutrons. Okay, I'm hoping that you are getting my point. And after solving this, we'll having the value of n like 6. This is being very simple. That's why I'm rushing it out. Okay. So this is being the thing. Okay. Now, if I'm talking about what about number of electrons? So for a neutral molecule, neutral molecule, for a neutral molecule, number of protons is equals to number of electrons. Number of protons is equals to number of electrons. If we are having a molecule which is neutral, so the number of protons which is present in it would have the same number of electron also. Okay, so in accordance of it, what we are able to observe that if the z value is 6, then the number of electron should be 6 also. Okay, it is just only applicable for basically just give me a second. It is just only applicable for when when neutral molecule is present. Otherwise, it is not applicable. I'm moving ahead then. Okay. So this is the thing. This is the thing. Now we are having a terminology which is called as nucleus. Nucleus. Nucleus is nothing but nucleus is nothing but we know about it also. Nucleus is nothing but it is basically a structure like this, a spherical shell in which there are protons. There are protons. Okay, there are protons, and there are electrons. Sorry, there are neutrons which is present in it. And because 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 there is a one more important thing which I need to explain you, which I have explained in also electric charges in field, that neutron has neutral charge. So because of it, the neutron has a specific value like 0, and proton having the positive charge. and the value of it is 1.6 into 10 to the power minus 19 coulomb. And electron is having negative charge. So in accordance of it, minus 1.6 into 10 to the power minus 19 coulomb. Okay. So because of the protons, which is present, protons and neutrons present in it, proton having positive charge and neutron having zero charge. That's why nucleus nucleus is totally being positive, which is very which is understood to us also. Okay. There is a term which is called as nucleons. Nucleons. So what is this nucleons? Nucleons is nothing but number of protons and number of neutrons are also called as nucleons. Basically, if we are having basically in nucleus, as we are able to see that there are proton and neutrons are present. So in accordance of it, we can say like if 1, 2, 3, 4, 5, 6, 7, there are seven proton which is present in it. If 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, and there are seven neutrons, or sorry, there are six neutrons which is present in this nucleus. So what we can say that what is the number of nucleons that it is present in it, number of nucleons. Then the number of nucleons is nothing but it is 13. Okay, then the number of nucleons would be 13. So it is nothing but nucleons is the sum of the number of protons as well as number of electrons. Okay, okay, I'm moving ahead then. I'm moving ahead. I'm thinking that it is being clear to you. There is an important thing which I am going to explain you right here also. And what is that? What is that? Let's suppose we are having, let's suppose we are having basically spherical shell like this, or it cannot be said as spherical shell. And this is being, let me change the color. Okay. So if I'm talking about that, let's suppose this is, this is being the atom. And if I'm talking about like this is being nucleus. Okay. Okay, then what is atom? What is the, if I'm talking about what is the radius of atom? Then the radius of atom is nothing but it is of 10 to the power minus 10 meter. And if I'm talking about what is the radius of nucleus, radius of nucleus, then it is nothing but 10 to the power minus 15 meter. Sir, how we are able to know the values of this? Because this is being an experimental value that we have found about these. Okay, so basically, this is also being very clear to you. It is being a revision session, so I am hoping that you this know this much, or if you don't know, then you should be remembering these values from right now. Okay, so this is the radius of atom, and this is being the radius of nuclei. Sir, for sir, this is not being the general value first of all. Sir, this is not being the general value first of all. Why? Why? This is not being the general value. Why it is not being the general value? Or basically because the radius of the nuclei, the radius of nuclei will not be remained as same like this. Okay, so there is a relation in between them that the radius of nuclei is nothing but it is r naught a to the power 1 by 3, r to the power r naught into a to the power 1 by 3, where a is nothing but it is atomic mass, where a is nothing but it is atomic mass. Okay, I'm hoping that you are getting my point right now, what I'm trying to explain right here. Okay, I'm hoping that this much is clear to you. I'm hoping that this much is clear to you. Okay, I'm hoping that this much is clear to you. Now I'm moving ahead. Okay, now I'm moving ahead. Sir, what is this? This is being the formula to find out any kind of a this is being the formula to find out the radius of nuclei. Sorry, the radius of an atom to it is being the formula to find the radius of basic. Oh, sorry, to find the radius of nucleus. And what is this value of R naught? R naught is nothing but it is 1.1 to 1.3. 1.1 into 10 to the power minus 15 to 1.3 into 10 to the power minus 15 meter. Okay. Okay. I'm hoping that this much is clear to you. I'm hoping that this much is clear to you. This is being the value of R naught. This is being the value of R naught. Sir, what is this 10 to the power minus 15? Also called as This 10 to the power minus 15 is also called as Fermi. Okay, I'm hoping that this much you know, 10 to the power minus 15. Okay, so this is the all things that I want to explain you. Now I'm moving ahead. Okay, now we are having what is atomic mass unit. Okay, so I am going to explain this one also. What is atomic mass unit? It is nothing but when the 1 by 12th mass of carbon 12 atom is taken. Okay, 1 by 12th portion of the carbon 12 atom mass is taken. Then that is called as atomic mass unit. Atomic mass unit. Okay, sir, basically why the carbon atom, or basically why 1 by 12 1 by 12th of it is taken. So basically there are some logics regarding it. Carbon 12 found to be very stable in each and every kind of reaction, in each and every kind of molecule it is present. So basically that's why that's why carbon 12 is taken, and the portion of it is used as atomic mass unit. Okay, so I'm talking about if a particle, sorry, it is not visible to you. If the particle is being if the particle is being proton, then it has charge plus one. Mass would be like this. This is the mass which is in gram. So this is the thing which you need to note, that this is the mass which is in gram, and we are having another mass which is in atomic mass unit. Okay, and it has the value like this 1.0073116, and it also can be written like 1.0074 something also. Okay, and as we are having like neutron has the charge value like 0, and it has mass in gram like this, and the mass of this can be taken also like 1.0088. Okay, now I'm talking about electron. In electron the charge is nothing but it is minus 1. Okay, the charge is nothing but it is minus 1. Mass is taken as like this. This is in gram, and the value of it also can be written like 0.00056. Okay, this is AMU, and AMU is also represented by AMU is also represented by U. AMU is also represented by U. Okay, so in each and after completing this whole value, I am putting the unit also like U, where this resembles 1 AMU, and it is also called as unified mass. U is also called as unified mass. Unified mass. It is also called as atomic mass unit. Atomic mass unit. Okay, so and what is the value of 1U? If I am talking about the value of 1U, then 1U has value like 1.6 into 10 to the power minus 19. Okay, okay. So basically, just give me a second. Just give me a second. Just give me a second. It has like value. Value. Just let me solve it properly. One Avogadro number has the value 6.022 into 10 to the power minus 24. Okay, so one unified mass is nothing but it is 1.6. Uh, just give me a second. Mm, okay, then it is having the value 1.6 into 10 to the power 25. Okay, I'm hoping that I'm hoping that this is clear to you. 23. This 0.022 into 10 to the power minus 23. This one is 23. Right here we are having this is 23, and this is minus 24. Okay, I'm hoping that this is clear to you. I'm moving ahead. Now, basically, I am comparing some of the nuclei, type of nuclei basically. So, first of all, we have isotope. First of all, we have isotope. What is isotope? What is isotope? Isotopes basically are those molecules in which are those atoms or molecules basically are in kind of a nuclei in which the protons number are same. Protons number are same. Okay, protons number are same. Just give me a second. There is some noise pollution. Okay, so basically what I was talking about. Okay, isotopes. So basically, the proton which has same number of protons in each and every kind of atom, which possesses the same number of protons, and different number of neutrons and different mass number, then it is called as isotopes. Like I am talking about, just give me a second. Like I am talking about right here in this, but we are able to observe in this, but we are able to observe like here we are having as six proton and six electron. This is being the carbon isotope, and afterwards we are able to see the atomic number is not being changed, but the atomic mass is being changed and the number of neutrons also changed. Okay, and in this, but we are able to observe that the atomic number is not changed, but the atomic mass is being changed, and the of course number of neutrons also changed, which is eight number of neutrons. Okay, so this is these all three are same elements, but having the different properties of neutrons and different mass number. Okay, so I'm hoping that this is clear to you. Atomic mass number. Okay, I'm hoping that this is being clear to you. Now I'm talking about isobars. In isobars, what are isobars? First of all, isobars which has same atomic number. Sorry, isobars are which are having same atomic mass number and same atomic mass and different protons and different neutrons. Like in the example of argon, we are able to observe that basically argon is having 18 atomic number and atomic mass is being 40. And in the different case, in the different element which is calcium, calcium also contain 40 as atomic mass, but having the different value of atomic number. Okay, I'm hoping that this is clear to you. This is called as isobars. What are isotones? Isotones are nothing but which has the same neutrons, different protons, and different atomic mass. Each and every kind of a thing is different, but the number of neutrons are same. Like in this nitrogen and oxygen. Uh, in nitrogen, the atomic number is the 7 and atomic mass is being 14, due to which the number of neutrons is being 7. Okay, and if I'm talking about oxygen, oxygen has 8 atomic number and 16 atomic mass, but this one oxygen is being isotope of it also, isotope of itself. Okay, this oxygen is being the isotope of this oxygen itself. Okay, so this is isotope of this one, and we are comparing with that part. And after comparing that, we were able to observe there are 7 neutrons and here are also 7 neutrons, and due to this, what we can estimate that this is being isotones. Okay, so I am hoping that this much examples are clear to you, or if there is any kind of a doubt, then you can ask me, because I'm not having that much time right now to explain each and every kind of a thing in a very detailed way. But that's why I'm basically rushing it out. But this is also being in very detailed explanation. Okay, so I'm moving ahead now. Now, basically, I'm talking about properties of nuclei. Properties of nuclei. I have talked about size of nuclei as the radius of nuclei is nothing but as the radius of nuclei is nothing but it is R naught into a to the power 1 by 3, where R naught is nothing but it is 1.1 into 10 to the power minus 15 into 10 to the power minus 15 ranges to 1.3 into 10 to the power minus 15. Sir, which one we have to take? Sir, which one we have to take? In the question, there would be mentioned. If nothing mentioned, then you would take by 1.1 into 10 to the power minus 15 meter. Okay, 15 meter. I'm hoping that this much is clear to you. A is being atomic mass. A is being atomic mass right here. And after putting the each and every kind of a value correctly, then you will have the answer value also. Okay, you will have the answer value also. I'm hoping that this is clear to you. If this one is clear to you, then I'm moving ahead to the I'm moving ahead to the just give me a second. Okay, I'm hoping that this much is clear to you. I'm moving ahead now. What is volume of nuclei? Volume of nuclei. Okay, if I'm talking about volume of nuclei, then it is nothing but 4 upon 3 pi r cube. Okay, But you, so basically, right now I'm talking about density. Density is nothing but it is mass upon volume. Right? What is the mass that we are having right now? Density is nothing but it is mass upon volume. What is the mass that we are having for a basically nuclei? So basically, we know that atomic mass, atomic mass, which is represented by capital A, is nothing but it is number of protons plus number of neutrons. And what we know, one more thing, what we know as a one more thing, we know that electron mass, mass of electron, mass of proton, and mass of neutron. There is a quite relation. This is so much less, and this is almost comparable. Okay, mass of proton and mass of neutron is almost comparable. So because of the electron mass is being very less, we can completely neglect this. We can completely neglect this. Okay. On the basis of this, but we are able to understand that the mass of proton and the mass of neutron would gonna play a very important role. Okay. So on the basis of this, I am I am basically stating a new term which is called as M naught. Okay. I am stating a new term because in the replacement of a proton, I can write neutron, and in the replacement of neutron, I can write proton. So on the basis of that, I am assuming a new term which is equals to m naught. Okay. Then then what is the atomic mass? Sorry. What is the total mass of the nuclei that we are having? I am taking a new slide for this. So if I am talking about this, if I am talking about this, actually, if I am talking about something like this, then okay, if I'm talking about this, then what we are able to observe in this, here we are having some protons, here we are having some protons, and here we are having some neutron also. Okay, then how we are going to estimate that what is going to be the total mass? The total mass would be the number of protons and number of neutrons are present in it, right? So basically, the total mass would be the total mass would be A m naught. Sir, why this A m naught? Because A is nothing but it is the number which is representing that what are the number of nucleons are present in it. Okay, and this is just the number. But if we need to find the total mass, then we have to multiply the specific mass of each body to to the numbers in which they are present. Okay, that's why this is being m naught A or A m naught. I'm hoping that this is clear to you, and if it is not, then you can ask the doubt regarding it. It is similarly to Z Z E or ZP, which in which we have done in the atoms chapter. Okay, I'm hoping that this is clear to you. Then after solving this, what we are having density is nothing but mass, which is m naught A upon volume. Volume is nothing but 4 upon 3 pi r naught to the cube A. And after solving this each and every kind of a term, but we are able to observe that it is like this. Okay, this is being the density that we are able to observe. And if this is being the density, then what is an important thing which is to be noticed? What is an important thing which is to be noticed? That the density of nuclei do not depend on atomic mass. Okay, this is an important thing that should be that should be in mind. Okay, so basically, it is not dependent on atomic mass. So basically, what I'm trying to convey right now, that what I'm trying to convey right now, um, let me take something. Like let's suppose if the density is same for each and every kind of a nuclei, because sorry, if the density do not depend on atomic mass, then if we are having atomic number like 123, like we are having atomic number as 120, atomic mass, sorry, like we are having atomic mass as 240 something, like, okay. And here we are having another atomic mass which is likely to be 60 or 70 something. Then the density of this nuclei, density of this nuclei, and density of this nuclei is gonna be same. Okay, this is being a very important thing. Why? Density, because the density of both nucleus is being same. Whether whether it is having more number of protons and neutrons in it, whether it is having more number of protons and neutrons in it, or whether there is something, but it is not dependent on any kind of a number. It is just dependent. Sorry, it is not dependent on each any kind of a number. And basically, with this, the density of it is nothing but it is a to the power zero. And in this, what we are able to observe that the this nuclei is having less number of protons and neutrons, but possess the same density of the bigger nuclei. And that's why there is a common question which arises in mind that why heavy elements nuclei are unstable. Okay, sir, first of all, if I am talking about that this is being, let's suppose, nuclei 1. Okay, let's suppose I am assuming that this is being nuclei 1, and let's suppose this is nuclei 2. I am assuming that this is thing. Okay, then which one is stable? Which one is more stable? Which one is more stable? If I am talking about that part, then which one is more stable? Okay, so the answer is smaller nuclei, smaller nuclei or smaller nucleus is being stable. Why? Why? Answer is because 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 it is having it is having less number of proton, less number of proton, less number of proton, due to which due to which due to which the repulsion between them, repulsion repulsion between protons would be minimum, would be minimum. Okay, that's why if the repulsion is being minimum, then if the repulsion is being minimum, then of course the nuclei is going to be more stable. Okay, I'm hoping that this slide is clear to you. That this one is slide is clear to you. And how protons are attached to each other in nucleus. This is another question which arises. So basically, what I'm trying to convey that we have understood each and every kind of a concept right now. And there is one more thing that if each and every kind of a nuclei is packed in, if each and every kind of a if each and every kind of a proton is packed in, basically in nucleus, then how are they how are they present in it? How are they present in it? This is being the one of the most important question which should be in mind. Okay, which should be coming in mind. So basically, so basically, they are repelling each other. They are repelling each other. There is no doubt in it. It is not like it is not. They are not following. They are not following Coulomb's law. They are following Coulomb's law, but but they are following Coulomb's law. But they are having a more stronger force. They are having a more stronger force, which is called as nuclear force, which is called as nuclear force. Okay, which is called as nuclear force. There is a more stronger force which is present right there, and that is called as nuclear force. So, but basically, what is nuclear force? Okay, so I'm writing over here. Nuclear force is nothing but it is the most strongest force, strongest force. It is the most strongest force in the world which tries to, which basically, which offers force of attraction between between protons, neutrons, neutrons to neutrons, and protons to protons, protons to protons. Okay, protons to protons. Just give me a second. Protons, neutrons. Okay, protons to protons. Okay, and why is it being so that it is being the most strongest force? Because in the nucleus it is having very less size, and in that there are so many protons which are present in it, and they are applying a force on each other, that is Columbian force. And after that part with having such great force, they are not the nucleus is not basically exploding with some protons. They are basically packed in. That's why this is being the most strongest force. Okay, what is the range of force that it offers? Basically, order in Fermi. Order in Fermi. Basically, what I'm trying to convey that the force is applicable. A force is applicable in few Fermis. Force is applicable in few Fermi. Okay. So basically, like if the proton is right there, then then a proton or neutron is right there, and of course there can be more molecules like that. Then the force is applicable to just a few Fermis. It is not applicable to so much Fermi. That's why we are not able to observe. We are not able to experience this force. Otherwise, if we experience this force, then so much things would have happened to us. Okay, I'm hoping that you are able to understand what I'm trying to convey right here. Okay, so basically, this is having the order in Fermi. Okay, and this is also being short range force. This is being short range force. Okay, this is another thing which I wanted to mention. So what is the nature of force? Nature of force is nothing but attraction and repulsion, attraction and repulsion. So basically there is a thing that is written like force of attraction between protons and neutrons. After some distance it also offers some repulsion. Okay, nature of force, attraction and repulsion. So what are you saying? I'm trying to convey that it offers attraction when the distance is under in zero point 0.2 Fermis, is under in zero point 0.2 Fermi. But afterwards it offers a repulsion. Afterwards it offers the repulsion. If it is greater than zero point 0.2 Fermi, then what we are able to observe then what we are able to observe that there would be a repulsion force which would be acting on it. Okay. Now, what is strength of force? Strength of force is nothing but it is the most strongest force in the world. Okay. I'm hoping that you are able to get this point up. Okay. If it is clear to you, then let me know about it. Okay. I'm hoping that this much is clear to you. Afterwards, afterwards, and basically most strongest force in the world. It acts between proton neutron. It acts with neutron to neutron. It also acts with proton to proton. So that's why it is being the most strongest force. Now, independence of charge. Okay, it do not shows any kind of a dependency. Do not shows, and basically it is clear to you. That's why do not show any kind of a dependency on each and every kind of each and every kind of a charge. Force is same for everybody. Force is same for everyone. Okay, I'm hoping that this much is clear to you. Spin dependence. Yes, it is basically spin dependent. Like as we are able to, as we know that if basically electron possesses two kind of a spin, like this one, in clockwise direction, like in clockwise direction, and there is another spin which is associated with electron. And what is that? In which direction? In anti-clockwise direction, right? So basically, on the basis of spin, there are some on the basis of spin, it also shows basically force value as a like the spin is rotating in the same direction, like as in the spin is rotating in the same direction, then force would have force would have minimum value. If they are spinning in opposite value, like if this one is moving like this one, oh sorry, this one is clockwise and this one, okay. So basically, okay, this one, okay. So force would be maximum. This is the all data which is not of course told by me. This is the data which is experimental. Okay, non-central force, unlike gravitational force, gravitational, electrostatic force. This is the force which is non-conservative. This force, this nuclear force, is non-conservative in nature. Is non-conservative in nature. Okay, okay. I'm hoping that this is clear to you. Non-conservative in nature. Okay. Position dependence basically what I'm trying to convey with this point. Force is dependent on position uh, of nucleus which is inside nucleus. Basically, if if basically nucleons is present in the nucleus. Okay, position dependence means if the one proton and one neutron is having like in this direction, in this distance, then they would offer some strong nuclear force. But again, but again, as the distance decreases, then the force would become weak. Okay, weak nuclear force. I'm hoping that this much is clear to you. It is first order force means it would act maximum on maximum on neighbors neighbors first. Okay, neighbors first. Afterwards, it would act to basically far away charge. Okay, so basically, it is the first order force also. I'm hoping that this much is clear to you. If this is not clear to you, then let me know. And if there any kind of a doubt, then you can also ask me. Okay. Now, what is the nuclear stability that we are having? What is nuclear stability? Nuclear stability is nothing but there is a graph which is observed. There is a graph which is observed, as you are able to see that there is a line which is going like a straight line. Okay. It is following a straight line like this. I have marked with red color. Okay. That it is observed that the n upon z ratio for atomic number which are having atomic number, sorry, which are having basically atomic number less than 20, atomic number less than 20 or equals atomic number less than 20 or equals to 20, then the n upon z ratio is being totally 1, like as you are able to observe that like here somewhat I'm just drawing a line. Okay, give me a second. I'm hoping that this color is visible to you. Okay. Um, Mhm. Black would be good. And for this one, black should be good. Okay. So I'm able to observe that. But we have observed that for this much atomic number, that if it is less than or basically equals to 20, the n upon z ratio tends to 1. Okay. Most of the and atomic number which is less than 20 are most stable than others, most stable than others. It is also observed. Okay. By by because because density is same for everyone. Density is same for everyone, but number of protons, number of protons and number of neutrons are less. Okay, and that's why it has much more stability. Okay, sir, there is a nuclear force which is applied in it. So why are we considering Colombian force also? Because Colombian force is applicable everywhere where there is a charge present. Okay, and that's why nuclear force is also being the considered part, and there also is a electrostatic force which is also being the considered part right here. Okay,